are once again from Winners Tutoring Program. We will be focusing on functions, specifically dealing with exponential graph. I know exponential graph, it can be challenging to most of the learners, and it's very short. It only carries very few marks, but when it comes very tricky. But after this lesson, I believe that you will smile after writing your exam. So in an exponential graph, we are, for example, if you are given f of x is gonna be equals to b exponent x. Here they can put any letter, they can put a k, they can put an a, any letter. So you need to know the shape, whether it's an increasing function or decreasing function. So when you find it in this way now, y is equals to a b exponent x minus p plus a q and so on, it's when there is a shifting. P represents the shifting horizontally, Q represents the shifting vertically, which is also our asymptote in this situation. So here, if your value of B is greater than 1, it means our graph is gonna be an increasing function. This is how we're gonna have the shape of the graph. This is our exponential graph, which is our f. Let us have the example of b being greater than 1. These are the examples. 2 exponent x, 3 exponent x. Let me have it as a fraction. A 4 over a 3 exponent x. This is when our value of b is greater than 1. But if the value of b is between 0 and 1, our graph is going to be a decreasing function. This is our decreasing function. That's how it is. So let's have the examples of b being between 0 and 1. You can have a half. You can have 1 over a 3. Do you see what you are having? A smaller value, bigger value at the bottom. You can have a 3 over a 4. Another one is 4, maybe to the exponent negative x. So sometimes I can give it into this way. So you need to be able to apply your maths to see that your value of b is between 0 and 1. Let's just simplify and have a look. So if you factorize or factor out an x, this is what you're gonna have. If you go back, it takes you back to the same thing. This thing is the same as, okay, let me write it so that it can be very clear. This thing is still the same as y equals to, if you factor out an x, you're gonna have something like this. If you punch on a calculator, this thing is still the same as 1 over a 4. Then there is an x outside. You see that the value of b is between 0 and 1. So they can give it to you that way. But you know that x is coming from a reflection. So wherever there is x, it's because there is a reflection across the y-axis. So this is how the shapes of the graph that you must expect. Your b greater than 1 shape, b between 0 and 1, this will be the shape. So from now, we're gonna go to the sketching of the graph. Sketching of these graphs now. Let us sketch. Give you one example, which is f of x is given as a 2 exponent x. We want to have a sketched graph. How do you sketch this graph? You let y become 0 if you are looking for the x-intercept. 2 exponent x. If you apply your maths, you can apply the logs, but you're gonna get your x as undefined. So it means our graph, it won't have the x-intercept, and there is a reason why it's not going to have an x-intercept, or why it's not going to cut x. We will explain that. So to get the y-intercept, you let x become 0. Wherever there is x, I place a 0. I'm going to get this one as a 1, so it's going to be 1 and 0. But we know that exponential graph, it has got an asymptote like a hyperbola. But this one, it only has one asymptote. Hyperbola, it has two asymptotes. So in this situation, our asymptote is gonna be, it's represented by a q. But a q, we don't have a q here, so which means our asymptote is gonna be a 0. But that q represents the y. So it only has the y asymptote, which means it's the horizontal asymptote. So our asymptote now, asymptote is gonna be y equals to q, which is y equals to a 0, because there is no q. That would be your asymptote. Let us now go to the sketching of the function. If you sketch your function here, we're gonna have x-intercept. We are not gonna have the x-intercept. Why? Because we know that y is 0 here. This part will be our asymptote. That's why we got our x is undefined, meaning our graph won't arrive here, because that is our asymptote. Then let us go to the y-intercept. The y-intercept is this one. Y-intercept is gonna be 0 and 1. Then let us sketch the graph. Check the value of b. The value of b is greater than 1. So we say the shape is gonna be an increasing function. So this is how your graph is gonna be. This is our increasing function. Yes, this is how your graph is gonna be. Let us move to the one where b is between 0 and 1. And let us sketch that graph quickly. Remember, the reason why we sketch the graphs, so that we can be able to interpret, because you start by sketching in order for the things to become easy when you are interpreting the graph. So let's assume you are given f of x as 1/2 exponent x. So in this situation, we're gonna look for x-intercept. We let y become 0. Then if you solve for this, you're gonna get your x as undefined. So the reason why it's undefined is because your graph is not gonna touch the x-axis, because it's our asymptote. So let's go to the y-intercept. Y-intercept, we let x become 0. If you let x become 0, you're gonna get your y as a 1. So our graph or coordinates is gonna be 0 and 1. This will be our y-intercept. Let us go to the equation of the asymptote. Our asymptote is represented by q, but our q we don't have, so it's gonna be our equation of the asymptote is y equals to q, which will be y equals to 0. Let us go to the sketching of the graph. The sketching of the graph, this is what we're gonna have. In the sketching of the graph, our asymptote is this one, where y is a 0, that is our asymptote. Let us go to the y-intercept. The y-intercept is 0 and 1, which is 0 and 1, and our graph is a decreasing function. A decreasing function because the value of b is between 0 and 1. So our graph is gonna go like this. So take note, it's not supposed to touch your asymptote. Asymptote is a line where the graph will never touch. So this is what we're gonna have as our equation. So now I want us to have the sketching of the graph that has got a value of q now. Having a 2 exponent x minus a 4. We want to sketch this graph. Look for x-intercept. You let y become 0. 2x minus 4. Then what happens is that you transpose this one. It's going to be a 4 is equals to 2 exponent x. Then this one is still the same as 2 exponent 2, 2 exponent x. Bases are the same. You drop the exponent. Then our x will be a 2. In coordinate form, it's going to be 2 and 0. Let's look for the y-intercept. Y-intercept. We let x become 0. If you let x become 0, our answer will be a negative 3. The coordinates are going to be 0 and negative 3. Let's go to the asymptote. Asymptote is going to be y equals to q. But which one is our q? Remember, our q, it's a negative 4. Our equation of asymptote is going to be a negative 4. This will be your equation of the asymptote. Let's check on how we sketch the graph. And how you're going to sketch the graph, you indicate your asymptote. Your asymptote is a negative 4. The negative 4 is going to be somewhere there. That's your asymptote, a negative 4. Let's go to the x-intercept. X-intercept, it's a 2. 2 and 0. Let us go to the y-intercept. Y-intercept, it's a 0 and negative 3. It's just above 4. 0 and negative 3. Let us now sketch the graph. Check the value of b. The value of b is greater than 1. So if it's greater than 1, we know it's going to be an increasing function. Increasing function, it will go like this. Do you remember that I told you that this one representing the shifting? So our asymptote originally it was here. After it is shifted 4 units down. So same thing, the graph will shift 4 units down. This is how your graph is gonna be. So now I want us to go and have a look on possible questions that they can be asked if a graph is drawn for you. So, or if your graph is, they've already sketched the graph. So I want us to have a look on possible questions that you must expect if the graph is already sketched for you. So let's go and use the first example that we used at first, which is f of x is equals to a 2 exponent x. This graph and check the possible questions that we must expect. This is y, this is x. We said this graph is going to go like this. Then the y-intercept, it was 0 and 1. So let's check the possible questions that we must expect when a graph is given in this way. Then can ask you about the domain. Then ask you about the range. They can ask you about the equation of the asymptote. Then they won't ask you about the axis of symmetry. We won't have that question under here, axis of symmetry. Then they can ask you about the shifting of the graph. Then they can ask you about the reflection. So these are the questions that you must be able to answer. So here, in terms of the domain, so if you are looking for the domain, we said these are x values where the graph exists. So you check whether your graph exists on the negative x values and on the positive x values. Don't check whether it does exist down. Down, we are dealing in a range. So now our graph exists everywhere as you go to the left and everywhere as you're going to the right. So if that is the case, our answer is going to be x element of real numbers. It doesn't have a restriction. Then let us go to range. Range, these are y values where the graph exists. It does exist here on top, but at the bottom, you don't find your graph. Why? Because we know that this one is our asymptote. This graph will never pass and come the other way. So in this situation, your graph will be found, it's going to be y element of real numbers, but your y will be greater than the asymptote, means found after the asymptote. Our asymptote will be a 0, this will be our range. Let us move to the equation of the asymptote. Our asymptote, we know that this is the 1 and it's a horizontal line, so it will be represented by y because it's cutting the y. Or you can check your q, the value where you will find your q, that will be your asymptote. Our q now is a 0, so the equation of the asymptote will be y equals to a 0. Let us move to the shifting. The shifting of the graph, if they have shifted the graph 2 units to the right, shifting the graph 2 units to the right, it affects the x values. To the right, what sign do you find this side? To the right, you find positive. So you're going to write a positive and the value that it shifted with, 2 units. You take this and substitute wherever there is x. Why? Because x values are affected. So you're going to take this one, then substitute wherever there is x. So it's now going to be x plus a 2. Do you see what I was talking about at the beginning? Remember, I spoke about b exponent x plus q, here negative p. This thing represents the shifting, which is what is happening now. So now we are now moving to the shifting to the left. Shifted 1 unit to the left. Shifting to the left, it affects the x values. To the left, there are negative signs. You do the opposite is going to be positive, put a 1, take this one and substitute where there is x. Why? Where there is x is because x values are the ones that are affected. Wherever there is x, I'm now going to put what I just formulated. So it's going to be x plus a 1. That will be the shifting horizontal. So now we are now moving to the shifting vertically. So shifting vertically, you need to know how your equation is going to be. So if it's shifted vertically, our equation is going to be, let's assume shifted 3 units down. Shifted 3 units down, shifting it down or up affects the y values. But down, you find the negative sign. Then here you're going to put the negative, the opposite, which is going to be the positive. Remember, I shifted down, you find the negative, you do the opposite is going to be positive. Then you write the value that it shifted with, then you substitute it wherever there is y. Our equation was this one, 2 exponent x. Now it's now going to change. Substitute wherever there is y. So it's going to be y plus a 3 is equals to a 2 exponent x. If you transpose, it's now going to be 2 exponent x minus a 3. So remember, it shifted 3 units down. So which means this graph, if it shifts 3 units down, even its asymptote is now going to shift 3 units down. From 0, it's now going to go to negative 3. So this will be our new asymptote. So it does make sense. This is our asymptote. It is shifted 3 units. So this one, if it shifts 3 units, is now going to go to a negative 2. So our graph will now go in that way. So that's how your equation is going to be. So shifted now, let's assume now it's now shifted 5 units up. Shifted 5 units up. Shifting up affects the y values. You write y up, you find a positive sign, you do the opposite of positive is negative, write the value that it shifted with, and substitute this thing wherever there is y, because shifting up or down affects the y values. Then you go to your graph, which was 2 exponent x. Wherever there is y, I'm going to put y minus 5 equals to 2 exponent x. Then you transpose. If you transpose, you're going to get 2 exponent x plus a 5. This will be a new equation of the graph. So it will shift 5 units up. Even its asymptote now, it was on 0, now it's now going to be on 5. So that's how shifting works. So now we are now moving to the reflection now, the last part, which is our reflection. In terms of the reflection, You need to also know the shape of the graph or the new graph. How is it gonna be when we've done the reflection? So in this situation, our equation is, they want a new equation when, okay, before we go to the new equation, what if they shifted it, maybe, let's say, 4 units to the left and 2 units up at the same time? So we want the new equation. So you don't do them separately. They have to be placed on the same equation. So shifting 4 units to the left. To the left, it affects what? It affects the x values. So you're gonna write x here wherever there is x. To the left is this side. You see the negative sign, the opposite of negative is positive. So it's gonna say plus the values that is shifted with. It's shifted 4 units to the left, you put a 4. Then on y, remember I shifted 2 units up, you find the positive sign, you do the opposite is gonna be negative, so it's gonna be y minus a 2, then you transpose, so our equation will end up becoming something like this. They shifted upwards and to the left at the same time. So this will be your new equation. So we're gonna have both the P and the Q on our new equation. So now we are now moving to the reflection. They say a new equation when graph F is reflected across number 1, the x-axis. So if it was reflected across the x-axis, it's reflecting it in this way. So we want to know, do you see my hand is moving up and down? It means the y values are the ones that are affected. Only the x values remains the same. So our new equation, how is it gonna be? Don't confuse the reflection and the shifting. Reflection, we will place a negative wherever there is y, because y is affected. So this was our original equation. Reflected, y is affected, wherever there is y, I place a negative. So that's why you're gonna end up getting a negative 2 exponent x. That's how your equation will have a negative, because of the reflection. Originally, our P can never be negative. It's only negative because of the reflection. So I want us to have a look on how the shape of the graph is gonna be. So in terms of the shape of the graph, let's just draw the original graph. Our original graph, it was in this way, y, x. This is your original graph. This is the one. So I want us to reflect it in this way. We want to see the shape, how is it gonna be? Reflecting it in this way. The shape of the graph, this is what you're gonna have as the shape of the graph. It will be found now at the bottom of the x-axis. This is how the graph is gonna be. This is the new graph after reflection, the one that we got here. So remember I said, okay, this point it was 0 and 1. When it comes here, remember we said reflection in this way, it only affects the y values. The x value remains the same as 0. But the y value, wherever there is y, you place a negative. Even on this y value, we're going to place a negative. And it does make sense for this point to be negative 1. So that's how reflection works. So let us now move to the reflection now. Across the y-axis now, reflection across the y-axis. Let us check our across the y-axis. So we want a new equation. Our original graph, it was 2 exponent x. Let us check now, how is it gonna be? reflected across the y-axis, so reflecting it in this way. Reflecting it in this way, it only affects the x values because my hand is moving to the left and right. Wherever there is x, I place a negative because x values are the ones that are affected. So do you realize now that our x is now a negative? Let's check in terms of the shape, how our shape is gonna be if we reflect it in that way. Let's check the shape of the graph, how the shape of the graph is going to change. So you draw the original graph. This is your original graph. If you reflect it across the y-axis, you reflect it in this way, or this is the graph that you're gonna get, the shape, or you can reflect it in this other way around. The shape is still gonna be the same. So if you use this method, you'll never go wrong. It's called the winner's method. So in this situation, the shape that we got there, if you remember well, this is the shape that we got. Do you see that this shape we once dealt with it? We dealt with it when we were talking about the value of b. It's now a decreasing function. So how is it now a decreasing function? Remember, for it to have this shape, the value of b must be between 0 and 1. Is our b between 0 and 1? Yes, only after you have dealt with this or simplified this. That's how you will see that the value of b is between 0 and 1. So let us simplify this. If you simplify this, if you factor out an x, you're gonna get something like this. I factored out x. This thing, if you punch on a calculator, you're gonna get 1 over 2 exponent x. Do you see now the value of b is between 0 and 1. That's why you're gonna get a decreasing function. So basically, this is the part that we dealt with today. Know how to interpret, find a new equation, draw the graph. After drawing the graph, then you can interpret those questions. Then if you face challenges, you can just go through the process on how we dealt with it. It will take you to the right answer. So in our next lesson, we're gonna focus on the inverse of this graph. That will be our next lesson, on how do you deal with the inverse. Remember, we once dealt in another lesson with the inverse of a parabola. If you check there on our YouTube page, there is a recording of a video where we recorded the inverse of a parabola. So in our next lesson after here, we will deal with the inverse of exponential graph. So you need to know, it has got a lot of concepts, a lot of things that you need to know, that you cannot afford not to know those things. You can never go to the exam without mastering that part. So in order for you to be notified about our next video, just click on our notification button whenever we post a new video to get the notification.